Good morning, everybody, and welcome to this session of the Data Doctor. Today, we are going to take a look at totals, grand totals, subtotals, and custom totals, and how you use them in your worksheets and your vizzes. First, let's start by looking at where in the order of operation totals are calculated. The order of operations is simply the sequence that Tableau goes through every time you create a worksheet. Totals are created down here in step 9 of the order of operation, and that's after the data table for the individual worksheet is the structure is determined up here in steps 3, 4, and 5. After we've added data into that worksheet, done some calculations, get down here to step 9 and calculate the totals. Now, it's real important to understand that totals in Tableau are not calculated or determined the same way they are in an Excel spreadsheet, for example, or any other spreadsheet. In those cell-based systems, totals are determined by actually adding up the column of numbers that appear above the total. That's not the way it's done in Tableau. In Tableau, the totals are determined by going back to the data table that's underlined the sheet that you see and calculating the totals or the subtotals at that level, and not by not by summing a simple column of data that you see in the visual data. And it does make a difference in how the data is calculated. Let's take a look at how you would go about using grand totals. There's two primary ways. The first, you can go up to the top ribbon and on the Analytics tab, open up the Analytics tab, select Totals, and then select the level that you want to see, whether you want to see the totals on the columns or the rows or the subtotals. The one that I'm going to show you today, and the one that I use all the time because I tend to use the mouse a lot, is to drag the totals from the Analytics tab on the data pane. Go to the Analytics tab, open it up, see totals, drag that to the viz, and there you'll have your choice of either subtotals, column totals, or row totals. Let's see how that would work. That's Superstore data. I use Superstore data a lot because it's the same data that you got when you got your copy of Tableau. And I'm looking at nothing more here than category and subcategory data over the entire data set. And we've got the sum of sales. And if I wanted to see the totals, I'd go to the Analytics tab over here. I'd open it up and I'd drag totals to columns, and I'd get the total value of all the sales that are in the data set. That's $2.3 million. If I wanted to see the subtotals, I could add those in as subtotals. And now we've got a line for each category subtotals. These 4 subcategories, the total is $754,000 and so on. Now that's very easy to do. And if I wanted to, I could drag order date up here. We could see the sales by year, 2019 through 2022. And automatically we have the subtotals at the category level and the overall total by year. And we can now go back and add the total to the columns and get a column over here. That's the total across all 4 years, or the $2.3 million that we were looking at before we added year to the viz. And that's pretty easy to do. And it's very useful. It's something that we all should be familiar with and how to use them. But what happens if I don't want to see the total or the sum? I can come in and I can open up the green pill and I have total using, and I've got a choice of what I want to see here. Total automatic is what we just used. And for this case, it will use sum, which is the default. We could look at average, minimum, maximum, or we could hide the totals altogether. Well, if we look at average, you can see that now we get the average value, and that average is applied to all the subtotals and to the grand total line. So here I'm looking at the average of furniture category sales in 2019, 2020, and so on. And this looks like at the average of bookcases over the 4 years. But I don't have a choice of looking at the sum of columns and the average of rows, or the reverse. And that's something that you might like to do. And I'm going to show you how you can do that here using the same sort of example. Here we're just looking at the category level, and we're looking across the order dates. And I'm going to use this to illustrate how we would go about calculating a custom total. We're going to take advantage of a property of the total line, or lines created by the grand total module inside Tableau. And there is that there is one record, or the size of the values in that line equal 1. And it's the only place in your worksheet where size equals 1. So if we say if size equals 1, then I want to see the average of this LOD. And all this LOD is the category. It's by category and by year, the sum of sales, or these values that you see here. So if size equals 1, I want to see the average of those values. Any place else, I want to see the sum of those values. So we know that size equals 1 here in the grand total line. And because this is a table calculation, we can calculate that formula either across the table or down the table. Right now, it's calculated across the table. So what we see here is the average by year of furniture sales is $188,000. Office supplies is $182,000. If I go down the column, 2019 sales are the sum, $494,000, $472,000 in 2020. If I wanted to go down the table and reverse those, I could see the average within the category in 2019 is $164,000, and the sum across all rows is $754,000. Well, this is just one way you can get that grand total line or the subtotal line to do a custom calculation, calculate something different the way that it would normally do. Now, I want to spend some time and show you other ways that you can calculate totals and subtotals. But I think I need to start talking about averages, because the question comes up over and over again about how to calculate averages, or I got an unexpected result when I calculated the average. If I just take a measure and put it on the Viz and change the aggregation from sum to average, what is actually happening is I'm getting a calculation that is the sum of all the values in that particular metric, like the sum of sales, all the individual sales, divided by the count of the records that make up that sum. So you're getting the average by the count. And that may not be what you wanted. You might have wanted the average sales per order, or the number of orders per day, or the miles per hour, for example. And whenever I have a user that writes in and he says, well, I'm not getting the average right, I tell them to calculate the numerator and the denominator separately, and then do the math to divide the numerator by the denominator. And in these cases, if we were looking at sales, sales would be the numerator, per order would be the denominator. The per order tells you what the denominator is. Orders per day, the denominator is day. Orders are the number of orders. If you had miles, how many miles did you travel? Per hour, how many hours did it take? So the denominator would be hours, and the numerator would be the total number of miles. Okay, let's see how that works in a simple calculation. Looking at our Superstore data again. If I just take sales, and I've got it here at the category level, sales over the three categories equals at $2.3 million, and there's the $754,000 we saw before. Now, if I grab the total, if I grab the count of orders as it appears in the data frame, what that number actually represents is the number of records. It's not the number of orders, it's the number of records. If you're familiar with the sales invoice, for example, you can have a sales invoice that is one order, and there might be 3 lines on that order, and each one of those is an individual record. So there's 3 records on that order for one order. Well, the number of records in that data set, in the Superstore data set, is a little over 10,000 records. So the sales, the average sales, or the sales divided by the number of records, is $228,000. Or if we look at furniture only, the 754 divided by a little over 2,200 records is 343. But that may not be what you wanted. You may wanted the sales per order. Now, to do that, the first thing I would do is I'd calculate the number of orders. I'd count them. And just a very simple count key, order ID, will count the number of orders. And there are a total of a little over 5,000. There's 5,100 orders in that data set. And there are approximately 2 lines per order for 10,000 records in those 5,100 orders. So if I want to calculate the sales per order, I would then write the calculation as the total sales, that's this line here, divided by the count of the orders, that's that line there, and I would get a value of $455 per order on average. For furniture, it's 415 and so on. This is just an example of how sometimes you have to think your way through what it is you actually want to return as a result. Here I wanted the sales per order. I didn't want the average sales per record. I wanted the average sales per order. And then I had to go through a calculation on just how I would get that result. We're going to shift gears here a little bit for you. Another example that we see over and over again. Users come in with a question, they've got a calculation, they want to determine the top N of, let's say they want to know the top 3 subcategories, and then they want to group all the other categories into a single heading called Other, and they want to calculate the total of the other separate from the 3 subcategories. And ideally, what they'd like to do is they'd like to be able to use that in grand totals or subtotals or something like that. But unfortunately, you can't do that. We'd like to look at this record right here or something that looked like that. And I'm going to show you how to do it. And yes, it's some work to do that, but this is how you would go about doing the calculation. Let's start with this data right here. And this is nothing more than our Superstore data again. And the first thing I did is I calculated an LOD that returns the sales. I'm going to sum the sales by subcategory for each year. And in this example here, we're going to look at the year 2020, and I put that in context so that I'm looking just at year 2020, and I want to look at each one of the subcategories. Okay. I've also added into this chart a parameter for N, the top N, if you will. In this chart, we're going to look at the top 3 categories, and then everything else I want to call other. Well, to do that, I first need to calculate the rank of those categories. And I do that with a rank unique. This rank unique is a table calculation, and I total the LOD and I rank it descending. And that gives us a rank, and there's 17 subcategories. So the highest ranking is rank number 1 is chairs at $72,000, and the lowest ranking is fasteners at $567. Now, what we want to do is we want to assign we want these 3 categories, the top 3, to be their individual subcategories, and everything else we want to call it other. So we're going to do that with a calculation, pretty straightforward, simple calculation that just takes a look and says, well, if the rank is less than or equal to the value of the parameter, then call it by its subcategory name, or else call it other. And we're just going to put that up there. And what we'd like to do is we'd like to see these individual items, these individual sales, and then we'd like to see the sum of this for other. And to do that, we still have some homework to do. What I want to do is calculate a running total. And the running total here is just the running total down of these values. And you'll see why I'm doing that in just a second. We're going to put that in here, and we're going to calculate that not across, but down. And what we'd like to do now is I'd like to see these three values here separate, and I'd like to see that value for all these other values. And to do that, we're going to come in with another calculation. And this calculation gets a little bit involved. This calculation conceptually is it's very simple. All it says is, look, if the value of n, if the value of our ranking is less than or equal to 3, then sum the LOD. For anything else, I want to take this value, which is the total value. This is the grand total by year. This is the fixed by year total of sales, the total of this entire column, and subtract from it these first three values. And that's what we want to see in our chart. And I want that calculated down also. And now what I'd like to see in the chart, what I'd love to be able to do is just grab grand totals and put it down here and just see these first four values. But we can't do it. What we need to do is we need to hide all the values in columns that we don't want to see. And it's really very easy to do. We can come back in and we can say, well, if the rank is less than or equal to the top n or equal to the top n plus 1, then I want to see the value. I want to show the value. I also want to hide the value. And I wrote this out so that a year later, when I come back, I can read this and I can understand what I did. And it's coded very explicitly on what we're doing. And we drag that and select show. And now we're just seeing the values that we want to see. Now, I don't want to see subcategory, so we're going to hide that. I don't want to see the rank. I don't care to see the rank at this point. I don't need to see this LOD. We can pull that off at this point, and we can just leave these values here, or we could take that off. It makes no difference. And now I get our top end, the individual sales value, and the total other value. And if we change this to 5, for example, now we get the top 5 values and other total. Okay, you're probably saying, well, that was a lot of work, Jim, to get to that total. Yes, it is. And sometimes it takes some work to get to the total that you want to see. So it's important to understand how to calculate totals and also how to use the grand total line and when you can't use the grand total line. Some people have asked, well, what happens if I've got a condition? How does that affect our overall totals? Well, it's pretty straightforward. I can write this conditional statement as I just made this up. I said, well, if the category equals furniture and the profit's greater than 100, then include that in sales, else 0. And if we use that conditional statement, we calculate the sum of those values, and we calculate those values, they would look like these, where the total sales without that condition look like that. And I just threw the profit in so that we could see what it looked like. And those values, if I use grand total, on the grand total line, we get a total for each one of these categories. The conditional statement that I wrote, the total of those values is $123,000. The total of all the profit is those values, and the total of all the sales are those values. So grand total works very well with that sort of example. But there are some others where you can't use grand total. And I want to talk a bit about table calculations and what table calculations are. Table calculations are calculations that work across the table. They're very similar to what you might have done in a Excel or a Google spreadsheet, where you wrote a formula and then you copied that formula down a row or across the columns. Well, table calculations do the same sort of thing. They're working across a sheet. They're not working within an individual record like a LOD expression might work. So we might want to calculate a value that was giving us the total percent to the first year sales. And this is just our Superstore data again. I've got year and I've got month here. So 2019 broken down by month, monthly sales would look something like that. And the totals are the same that you would see each year. And I might want to calculate the percent to the first year sales or the first year. We're looking here at 2019 is the first year. And we can do it like this. And we can do this with a lookup expression. And this says just take the sales in the current cell and divide it by the sales in that first year, the sales in the first year in each one of these rows. So this value in 2019 divided by the same value in 2019 is 100%. And if I looked over here at 2022, for example, this $44,000 divided by the first year sales, which is $14,000, that's what this is right here. We're going across the table and I get a percentage of 300%. So it's 3 times that value. And we can look down here in December and we can see that the value in December is $72,000. In 2019, it's $85,000 in 2022. So it's 118%. And we can look down here in the grand total line and we can see that the total in 2019 was $494,000 and the total in 2022 was $745,000, or it's about 150%. And we're able to do that using the grand total line automatic, because automatically it went back and it took this table calculation and it says, I can work in this grand total line. And in the grand total line, I can look at the value that I've got in the cell, which is this value, and I can go to the first value in that grand total line and I can divide one by the other, and it works just fine. But where you can't do and where the things get difficult, and you can't do it in grand totals, for example, is if I wanted to take a look at the 3-month moving average. Let's take a look at the 3-month moving average. And I've got a 3-month moving average, and we're going to go down the column. And I've got the 3-month moving average. So we get down here, this value is the average of those 3 values. And this value is the average of those 3 values. And we get down to the grand total line. And all of a sudden, we don't get the average of the last 3 lines. And that's because of the table calculation itself. The grand total line can't use a lookup or a calculation that goes across several lines and tries to total those lines within the calculation. It just doesn't work. So most often what I would do when I had this type of calculation, I would just hide that total so that you don't see that total and it's less confusing that way. Now, there are other calculations we can do, and we can show you other calculations where we can get a proper answer even using table calculations. Here's an example that uses table calculations, and I'm sorry, it uses custom calculations to calculate the percent of total at several different levels in the same chart. Where in the last example, we ran into difficulty because we couldn't calculate across different records in the chart. This one, we're going to take a look and we're going to calculate at the individual subcategory level, we're going to calculate the percent of the value to the overall grand total per year. And we're also going to look at the subcategory total line, and this is the subcategory line that you would get from grand totals. We're going to take a look at the category percent to the total, and at a lower level in the subcategory line, we're going to look at the percent of the segment to the grand total, and we're going to do that all in one expression. And it gets kind of messy to look at it. This is what the chart's going to end up looking like. But let's take a look at the individual calculations that make up this chart. I've got an example here. I just want to take a look at calculating these numbers here. And that calculation is a simple sum of sales divided by the fixed year sum of sales. This is an LOD. That's the total sales in each one of the years. It just says for each year, total all the sales for that year. And I'm going to use that as the denominator. I'm not going to use the table calculation. I'm going to use the LOD version of the table calculation. And I'm going to use that as the denominator, and I'm going to divide sales by that. And that's what these numbers equal right in here. Okay. And if we were to take those numbers and total them across the entire column, they would total 100%. Now I can come back and I can take a look at this next level and take a look at the subcategory level and the category level. We're going to take a look at two different sets of numbers here. If we were to take a look at the subcategory level, this just says this just says this is the sum of sales for the entire year, and this is the sales by category for the entire year. And we do the same sort of thing, and we'd calculate the sales percentage by segment for the entire year, or divided by the sales for the entire year, the sales by segment for that year divided by the sales for the entire year. And then we're going to write one calculation. And this calculation is going to look, oops, wrong one, at all of those different levels at one time. And this is a different way, and this is the way we're going to look to find the individual subcategory lines and the total line using a custom grand total calculation. Do you remember before we showed you how to use size equals 1? And when we use size equal 1, all of the values were either the sum or all of the values were the average, but they weren't custom because they were each subcategory has a line that equals 1. And Tableau can't distinguish between the subcategories just using one size equals 1. But it can if I use this calculation. I can look at the segments and I can take a look and say if the minimum category doesn't equal the maximum category, well, the only place that occurs is in a total line or a subtotal line, okay? I can also look and see if the minimum subcategory doesn't equal the maximum subcategory. Well, if I look at this line here, for bookcases, for example, the minimum subcategory is bookcase, the maximum subcategory is bookcase, so it doesn't qualify, okay? But if I look down here at the total is a case where the minimum subcategory doesn't equal the maximum subcategory. And we can look down lower and we can take a look at the same sort of thing. The minimum category doesn't equal the maximum category. So we just changed categories is what this is boiling down to, or we just changed subtotals. Well, if that's the case, then I want this one calculation at the segment level. And if the subcategories don't match, I want this different total at the category level. And for every place else, I want the percent of sales to the total year. And that gets this chart, which has all the different levels that we're looking for detailed in the chart. And I can drill down into the chart and get the totals of the category or the segment to the grand total, or I can open it up and look at the individual items to the total. So we're able to look at 3 different levels of totals and subtotals in the same chart, but we have to do that with a custom calculation. I've got uh, one more example to show you, and this is calculating total duration. Very often we'll get users that come in and they want to know what the total time spent was, and they've got a number of records and a number of different steps, and they've taken a date difference to calculate time. And they say, well, how do I calculate these things, and how do I add them together and get the total time? Well, the first thing we have to do is we have to recognize that time and duration aren't really the same thing. I can look at a clock and I can see on the clock it's now 11:23 a.m. my time. I can look at a clock, I can see that. You can say, well, what's the duration? You'd have to say, well, when did you start and how many hours went by between the start and the end? And now I can add up those hours together and then I can look at parts of an hour. Well, that's how you have to calculate duration. Okay. And I just made up an example here. I've got a target date that includes a time on it, and I got an end date that includes a time on it. And I want to take the duration or the time difference between those two dates and create a duration out of that. Well, the way you have to do this inside Tableau is start at the lowest level and then do the math, as I would say, to get to higher levels. And at the lowest level, you want to take a look at the duration in minutes. I can take this example here and I can take the date difference. And I did this as an LOD. Okay, so I said for each process, I want to look at each one of these lines. I want to take the difference in minutes, the lowest level that I'm going to work with, between the target date and the end date. Okay, between that date and that date. Okay, and it's going to return a value. And these are the number of minutes. And you say, well, that's fine. That doesn't do us a whole lot of good because I have no way of relating to 19,000 minutes. I want to see it in days, hours, and minutes. Okay, let's start at the day level and we're going to calculate the number of days that is. And here's where you just plain do the math. And I take this LOD expression, and I'm using an include statement here, to, at the process ID, take the duration in minutes, that's this thing we just calculated, and divide it by 60 times 24. And I want the integer value. Well, 60 times 24 is the number of minutes in a day. So this is going to give me, when I do this math, it's going to give me the whole number, including the decimal part, of the number of days. And I only want to see the integers, so I'm looking at the number of days, and I get that value. But I've got hours left over. So now I want to come back and I want to take a look at the hours. And to do that, I want to take a look at, this is the same type of number that we were just looking at, where we were looking at the duration of minutes divided by the number of minutes in a day. And I want to divide that again by 60 because there's 60 minutes in an hour. And I want to get the integer part of that again so that I'm getting whole hours. And we're going to come back later and we're going to worry about the minutes involved. So I can get the whole hours, and that's this column here. And then finally, I can calculate the number of minutes. And the number of minutes is the remainder of taking the duration in minutes and using this property here. This property here, and I always say this wrong, I think it's pronounced modulo. It's the remainder that's left when I take this total and divide it by the 60 minutes in an hour, and it's going to come back and it's going to give me a remainder. If you remember doing long division, you know, that remainder that's left over is what we're looking for here in terms of number of minutes, and I get those minutes that are calculated here. So I've got days, hours, and minutes in total. Now, those days, hours, and minutes can be aggregated using our automatic grand total line. And the days, hour, and minutes will total properly that way. Okay. I want to thank you for your time today. All of what you've seen today is not just recorded. but I also have a post out on my blog, and that's jimdehner.com. And here's the QR to get there. It's right here, this totals, grand totals, subtotals, and use cases. You can use that. Everything we talked about is coded there. There's also a downloadable workbook. There's a link you can get to using this from this blog post. You can also go directly to my Tableau public site, and here's the QR for that, and you can download it there. Or once you're on either the blog or my Tableau public site, there's a wide variety of topics that I've talked about in the past. Thank you very much. I enjoyed being with you today. Bye now.